For any of these notes, just choose one, G, and I'll turn on the volume to high. For any of these notes, position the speaker very near the opening, but not touching. And then you can move the plunger and you can locate areas where you end up having resonance, and it'll be very apparent when you hear it. The sound will get louder. So right there, I've discovered a node. I'll mark it. Then if I move the plunger out until I hear resonance again, right about there, mark that location. And now I'll turn the sound off. So what I've done is I've moved the plunger to discover positions where I hear resonance occurring. When resonance occurs, there's a standing wave in the air column, and the plunger's location is at a node of that standing wave. So what I've done here is, by moving the plunger in and out, for this particular note I was playing, which again was G, I've located the locations of two adjacent nodes when you have standing waves and resonance in the air column. So the distance, I can measure the distance between these nodes. The distance between these nodes is equal to 1/2 the wavelength for the standing sound wave that's generated inside the column. So if I change the note, the positions of the nodes will change because I'm changing the frequency of the tone, which is changing the wavelength. So the positions of the nodes will change. So for different notes, I can measure determine the location of adjacent nodes and then measure the distance between them, giving me 1/2 the wavelength.